Hey guys, so today I'm going to show you how to find the axis of symmetry, vertex, and the y-intercept of a quadratic in standard form. Here's your standard form. F of x equals ax squared plus bx plus c, where a, b, and c are integers, okay? So there are three things we're going to find with our standard form quadratic: axis of symmetry, vertex, and the y-intercept. So in the notes I also posted for you, it gives you some definitions about what the axis of symmetry, vertex, and y-intercept are. So let's look at our first example. Okay, our first example is f of x. F of x is just a fancy way of saying y, okay? F of x equals 2x squared minus 4x plus 5. And what you want to do is you want to label your a, b, and c right away. So this is your a, this is your b, and this is your c, okay? So we're going to find the axis of symmetry to start with our quadratic. And the axis of symmetry is where it cuts the parabola in half into two equal parts. So it's usually a straight up and down line that cuts the parabola in half. And in order to start finding the axis of symmetry, which is also starting to find the vertex, is using x equals negative b over 2a, okay? So we're going to plug in our values into this little formula. So negative b, meaning whatever b is, but b is negative 4. So if it's negative b and your b is already negative, that means it's going to turn into two negatives, give you a positive 4 over 2 times a. What's a? Positive 2. Okay. So with that, we have 4 over 4. 2 times 2 is 4. What is 4 over 4? 4 over 4 is positive 1. So your axis of symmetry, I'm going to put to the side because this is part of your answer. Axis of symmetry is, what was it equal to? X. X equals 1. That's your answer for axis of symmetry. Okay. Your vertex is always x comma y, and we already found what x is. So x is positive 1. We got to find the y. So in order to find the y of that vertex, we have to take 1 and plug it in for the x's in our formula. So we have f of x equals 2 times 1 squared, okay, minus 4 times 1 plus 5. Now we just have to simplify this. Well, what is 1 squared? 1. So we just have 2 times 1. Negative 4 times 1 is just negative 4 plus 5. What is 2 times 1? Just 2 minus 4 plus 5. And what is negative 4, 2 minus 4 plus 5? Positive 3. So your y value, because this really is y, okay, is in your vertex positive 3. That's your vertex. So we found the axis of symmetry, the vertex, and now the y-intercept. Y-intercept is an x and y point as well, where your x is always 0. And your y-intercept of every standard form quadratic is the c value in your quadratic. So the c value in this example was positive 5, so it's 0, 5. And that one's finished. let's go to example number 2. Okay, so right away, we need to label we have our standard form quadratic. This is my A, this is my B, and this is my C. We're going to take the same steps that we did in the first example. So right away, to start, you have to write down your x equals negative b over 2a. Well, again, negative b. B is negative 10, so 2 negatives give you a positive 10 over 2 times what a is. What's a? Negative 5. So now we have 10 over negative 10, because 2 times negative 5 is negative 10. What is 10 over negative 10? Negative 1. Okay, so right away we just found our axis of symmetry and half of our vertex. So axis of symmetry is x equals negative 1. Okay, then your vertex is negative 1 comma something. We don't know what the y is yet, so we need to find this y. So we're going to take this negative 1 and plug it in for all the x's in our quadratic. So we have f of x equals negative 5 times negative 1 squared minus 10 times negative 1 minus 2. So now let's finish solving. Negative 1 squared is positive 1, so we have a negative 5 times 1. Negative 10 times negative 1 is positive 10 now. 2 negatives give you a positive. So now you're left with negative 5 times negative 1 is negative 5 plus 10 minus 2. We'll plug these all in. Negative 5 plus 10 minus 2 gives you positive 3. Another positive 3, just like our first example. So now our vertex is negative 1 comma 3. And that's done. And now for the last thing is the y-intercept. Y-intercept is always 0 comma whatever the c is. Whatever the c is, what's the c? Negative 2. So 0 comma negative 2 is your y-intercept. And that's it. That's how you find the axis of symmetry, the vertex, and the y-intercept. So we're going to flip over to the back, and we're going to do 2 other different examples of finding a maximum or a minimum value of a quadratic formula. Okay, so the first thing you need to look at is your a value. So let's label our quadratic A, B, C. Okay. Our a value is equal to positive 5, which means what is that in relation to 0? 5 is greater than 0, okay? So what that means, when you have an a value that is greater than 0, your parabola is going to open up. It's going to open up. And, okay, it's going to have a minimum. It's going to have a minimum value, okay? It's not going to have a maximum. It's going to have a minimum value. So in order to figure out what that value is, we need to use our x equals negative b over 2a formula. So what is negative b? Negative b is negative 15 over 2 times 5. Okay, negative 15 over 10, which really equals negative 1.5. Okay, so our value, the value is always the y. The value we're trying to find is always the y value in our vertex, but we just found the x value of our vertex. We need to find the y value because that's our final answer. So how do we find the y value of the vertex now that we have the x? We got to plug this back in. into our x's. So we have f of x equals 5 times negative 1.5 squared plus 15 times negative 1.5 minus 10. So let's simplify. We have negative 1.5 squared is going to give me positive 2.25. Now we have a positive and a negative with multiplication, so this is going to be a negative, but what's 15 times 1.5? 22.5. Bring down the minus 10. Okay, next we have positive 5 times 2.25, which gives me 11.25 minus 22.5 minus 10. Now you just plug that all from left to right in your calculator and you get how much? Negative 21.25. So you could say is minimum value. Okay, so nothing different, nothing crazy different than the first two examples that we did. We still use our negative b over 2a formula, and we still had to plug it in to get the y value, and this is our final answer. So now we'll go to our final example in finding the minimum and the max, and we need to identify all of our pieces in this quadratic that we have here of g of x. So this is my a, my b, my c, okay? My a in this case happens to equal negative 4. Well, what is negative 4 in relation to 0? Negative 4 is less than 0. So guess what? This parabola opens down, which means it's going to have a max. It's going to have a max if it opens down. So now we have to use our negative b over 2a to start finding this maximum value of this parabola. X equals negative b over 2a. So what is negative b? Well, b is positive 4, so it's going to be negative 4 over 2 times negative 4. That's my a. Negative 4 over 2, negative 4 over negative 8. Which turns out to be a positive 0.5. Okay, so my x value of the vertex is a half, 0.5, and we really need to find our y value because that gives us our maximum value in this case. So we have to plug this 0.5 into our original quadratic here. So we have g of x equals negative 4 times 0.5 squared, don't forget the squared, plus 4 times 0.5 minus 2. So now, you always do your squared first. 0.5 squared is negative 4 times 0.25. Plus, what's 4 times 0.5? 2. Minus 2. Bring down the minus 2. So now you have to calculate this multiplication. Negative 4 times 0.25 is negative 1. Plus 2 minus 2. So now you have no more decimals anymore, nice whole numbers, which gives you a value of negative 1. So what does that mean? That means negative 1 is your max value. And that's how it's done. Hope this helped, guys.